me introduce our group member. My name is ALEEYA RASZQUIN binti Mat RASBE and my MOHD ID is 2022-699-054.
I am HERIKA ZUREEN binti RUZAIDI and my ID number is 2022-834136.
My name is SYAFIQAH binti MANAN. My MOHD ID is 2022-814-766.
My name is FAIZA IRDINA binti FAUZI. My nometric is 2022-699-196.
My name is Mat222-Laws FAISAL and my student ID is 2022-880526.
Logic is a field of study that deals with methods of reasoning and thinking in a very systematic way, while law of logic present first principles before reasoning begins. The law of logic also fundamental assumptions, rules which rational discourse itself is often considered to be based. The formulation and classification of such rules have a long tradition in the history of philosophy and logic.
However, such classical ideas are often questioned or rejected in more recent development. There are types of law that used when answering questions related to this topic. Each law has its own rules to show the difference between all types and how to apply them correctly based on what the question asks for.
For the first outline, we will talk about the law of logic. There's contains 13 laws, so let's get through it one by one. Let PQR be a simple statement, T for tautology, and F for contradiction. First, there are law of double negation. When we counter a double negate, we will cancel it and become a normal. Like for example, double negation P will be P. Second, there is a De Morgan law where the negation will multiply in the bracket and the symbol will change. For 3, commutative law where we just change the position of the simple statement. For associative law, we'll just change the position of the bracket and the symbol will remain the same. Next, distributive law, where one simple statement will multiply with every simple statement in the bracket. For example, as you can see, P or bracket Q and R bracket, we will get P or Q bracket and bracket P or R. The next discussion, we will talk about idempotent law. Idempotent law, when one simple statement will counter with the simple statement itself. For example, as you can see between these two examples, I will say only one. P or P, we will get P. For identity law, where this simple statement will deal with contradiction F and tautology T. As you can see, P or F, that is contradiction, we will get P. For inverse law, the variable will deal with their not and it will get either tautology or contradiction. For domination law, when one variable deal with tautology and contradiction, and we will get either tautology and contradiction. For absorption law, where one variable will deal with variable itself in the bracket, and you will get itself. For example, P and bracket P or Q, you will get P. For definition of implication, where P implies Q, you will get not P or Q. For contrapositive law, you will change the position of the both variable, and we will change the symbol of both variable. For biconditional identity law, we will get in to out or out to in. For example, you can see in this slide too, P by conditional Q, you will get P implies Q and Q implies P. So that's it for the law of logic.
So, to understand more about this topic, let's look at the question. For example 1, show that P and not Q and P and Q is a contradiction by the law of logic. So, from the statement, we can use commutative laws and get not Q and P and Q. After that, we can apply associative laws to combine them in a one bracket, and we get not Q and P and Q. Since we can see P and P are already sitting next to each other in one bracket, so we can apply idempotence laws and get not Q and Q. Next, we can use commutative laws and we get P and not Q and Q. Then we can apply inverse laws and get P and false. Lastly, we can use domination laws and get false. So it shows that the statement P and not Q and P and Q is a contradiction.
Next, I'll be explaining the example 2, which is negation Q implies P and P and R or P and negation R. First, we'll be using definition of implication on Q implies P and turn that into negation Q or P. Next, we'll be using De Morgan's law on the first half of the equation and turn that into negation Q and negation P. After that, we'll be using law of double negation and turn the negation Q into Q. And for the second half of the equation, we'll be using distributive laws and turn P and R or P and negation R to P and R or negation R. Then the R or negation R, we'll be using inverse laws and turn that into tautology. Thus, by using identity laws, we can change P and tautology to P. After that, we'll be using associative laws by changing the brackets of Q and negation P to negation P and P. For the negation P and P, we'll be using inverse laws and turn that into contradiction. And last but not least, we'll be using domination laws on Q and contradiction and turn that into contradiction.
Example 3. Not R or S implies not S equal to T. First step, we do definition of implication, which we remove the not in front of R or S and we change implies to or. Next step is associative loss, which we change the bracket to S or not S. Then inverse loss, S or not S, we can get T. Last but not least, R or T, we will get T, which is domination loss.
Next, example 4 to prove A or B or in bracket not A and not B and C is logical equivalent to A or B or C. First, solve left hand side by multiply B and sign off with all in bracket. That's called distributive law. Next, use inverse law in red circle and get T. After that, use associative law to change big bracket. Next, use identity law and get that small bracket. Next, multiply A and sign off with all in big bracket. Next, use commutative and associative law. This part, we use inverse and domination laws and get T. Lastly, use identity law and it gets similar with right hand side. For conclusion, we can apply the following list of law. Name the law of logic to establish the logical equivalent. Next, based on the example given, there are no specific ways to answer the question.
Lastly, we have to apply equivalent identities to reduce a complex statement into a simple one.